Good morning. I am Cadet Ed Nyer, and I'm going to be going over the Sprint 1 tasks for the CNS 5000 GPS sensor on IGI. So the IGVC Sprint 1 goal, just to reiterate, is to familiarize the team with sensors, file navigation, and code repository. So how this fits into that, the goal for the CNS 5000 sensor is to familiarize with the sensor, the IMU, and other components of the GPS sensing, understand the results from the 2016 competition, and gain knowledge on data acquisition for the sensor using the ROS files already on IGI. Understand how the sensor sends and receives information, and develop a test plan and build test interface for sensor to execute in future sprints. So the knowledge acquisition portion, the IMU on the sensor, it stands for internal measurement unit. Communicates the data through the serial port. The IMU serial port settings and data communication must match. That's important to know for any errors troubleshooting in the future. That could be a source where the IMU and the data communications are not matched. The CNS 5000, more details. It has three main components. The fiber optic gyro, which detects the angular velocity, so it can detect a change in position. The IMU, which we already talked about, and the precision receiver, or the internal navigation system. The internal navigation system processes the raw data from the GPS and IMU and outputs internal navigation of position, velocity, and altitude, and it'll input that into the ROS code. You'll see in a minute. Moving on, we have the data sheet, page 1 for the sensor. It discusses most of the things we just talked about. Here's some more tables of specs of the sensor. So going over specifications the sensor has that will be fit into the test plan. Okay, so then the data acquisition, familiarizing with how the sensor gathers data. So using the ROS files from IGI, understand how to call the sensor. So we moved. I moved the files from IGI to ROS 08 laptop. This is going to be helpful for the test plan, and then moving on from there with troubleshooting. So then to access the GPS IMU file, you just ROS run that after you're already in the correct package. So the sensor test on 19 October, took the CNS 5000 out to make sure that it was operating correctly using the IGI files. I did this just to make sure that there was no problem with the files that were already on IGI. So we used the test platform and the antenna to drive around West Point and gather data points to ensure the motor was properly functioning. And we tested to make sure that IMU and GPS were sending reliable data over their serial terminal window. So down below, these are the survey points. This is from the ROS terminal window that the sensor was spitting out. So this shows that it was working. Just further research needs to be done to figure out the significance of the WGS 84 and the WAAS up here. That'll be done during the next sprint in the test phase. So going over here, this is the test platform that we built. So it's just a block of wood. This is the sensor. In it is the IMU, the gyro, and the internal navigation system. So that's all in here. Here's the battery, it supplies it. And then this is the serial port. Let's see. This one is the IMU, and then this USB is the GPS. Here's the antenna that we used. During the test plan, we're going to use both antennas, and then we're going to use that to find the accuracy of the sensor and to figure out if there are any errors with it. That concludes the sprint for the sensor.